Now let's return to the question of how we can use numbers to represent text. Well, let's say we want to represent the word banana. Well, if each individual character in our alphabet corresponds to a number, we can represent the word as a sequence of numbers. So here, for example, if B is represented as 2, A as 1, and N as 14, then the word banana is the sequence of numbers 2, 1, 14, 1, 14, 1. And say we write that stream of numbers to a file, well then if a program later reads that file and it assumes it to be encoded in this fashion, it can read back the numbers 2, 1, 14, 1, 14, 1 and know that those numbers corresponds to the sequence B-A-N-A-N-A. Note that in this example, we've represented each letter with the number that corresponds to that letter's position in the alphabet. So A is the first letter in the alphabet, so it's 1, B is the second letter in the alphabet, so it's 2, and so forth. This way of assigning numbers to letters, it works perfectly well, but just understand it's really arbitrary. If we were so inclined, we could pick effectively random numbers to represent particular characters. So say A doesn't have to be represented as 1, it can be represented as 97. All that really matters is that the programs that read and write the same text data have to agree on what number corresponds to what character. So if my program has it that the letter A corresponds to the number 97, and you write a program that wants to read my text data, well, your program has to also have it that the letter A corresponds to the number 97. So it is basically arbitrary which number we use to represent any particular character, but it would be a huge mess if every program in the world decided that it's going to have its own way of mapping numbers to characters. So that's why we have what are called standard character sets. A character set is just a standard agreed upon mapping from numbers to characters. The most widely used character set for many decades is called ASCII, ASCII, which stands for American Standard Code for Information Interchange. ASCII consists of just 128 characters, and as you would expect, it's American, so it covers the English alphabet and really not much else. We have 26 letters in the alphabet, and for each letter we have an uppercase character and a lowercase character, so that's 52 characters right there. ASCII also has 10 characters for the 10 numerals 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. Then we need a few dozen characters for punctuation, periods, commas, parentheses, angle brackets, and so forth. And less obviously, we need what are called whitespace characters. As the name implies, a whitespace character is a character which represents spacing. Most obviously, you need a character to represent a space. So for example, if you have the text a banana, well there's a space in between a and banana, and that has to be represented in the data somehow. So we insert a character which represents that space. And in ASCII, the space character is mapped to the number 30. And also notice here that uppercase A is a distinct character from lowercase a. Lowercase characters and uppercase characters are not the same characters. So uppercase A in ASCII is the value 65, and lowercase a in ASCII is 96. Aside from the space character itself, ASCII has a few other whitespace characters including tab, line feed, and carriage return. What's confusing about these other whitespace characters is that not all programs treat them the same way. So for example, the tab character is meant to represent some amount of indentation. How much indentation, though, is left up to individual programs. When some programs display ASCII text, they make a single tab character effectively the equivalent of, say, 8 spaces, and then other programs might make it the equivalent of 4 spaces. So the same text file opened in different programs may not have the exact same spacing. The line feed and carriage return characters are especially problematic. When ASCII was originally created in the 1950s, the only way that a computer would display text is by printing, and the printers back in those days worked like electronic typewriters. When you get to the end of a line with a typewriter and you want to move down to the next line, well, you have to do two separate things. You have to return the carriage, that is, slide it from the right back to the left, and then you have to advance the page up by one line, hence line feed. So the problem is that when we work with text on a computer, we usually think of hitting the enter key as inserting a paragraph mark. But there is no such character in ASCII. There's line feed and there's carriage return. The problem is that not all programs agree about how to represent a paragraph mark, whether you should use a line feed a carriage return, or whether you should use both. For a long time, the prevailing situation is that on Unix systems, the convention was, in ASCII text, to use just a line feed character to represent a paragraph mark, whereas on Mac systems, Macintoshes, they decided they wanted to use a carriage return to represent a paragraph mark, and Microsoft decided that the convention should be a paragraph marker is represented as a carriage return followed by a line feed. It would actually be two characters right next to each other. What this then meant is that when you wrote text on one system and transferred it to another, you end up with either too many or too few paragraph marks. Today, this isn't as big a problem as it once was because most programs which read ASCII text will interpret either a line feed or a carriage return or a combination of the two as a paragraph mark. Now, the whitespace characters in ASCII are actually considered examples of what are called control characters. A control character is a character which, when read by the program, is meant to trigger an action. So for instance, a line feed character and a carriage return characters, those actually represent actions. With the old style of electronic printer, the line feed character is meant to trigger a line feed, and a carriage return character is meant to trigger a carriage return. Other control characters include form feed and the bell character. The form feed character was generally used to trigger an actual feeding of a form, that is, advancing a whole page rather than an individual line on the printer. And the bell character, oddly enough, was used to signal a bell, and that was useful to alert people, like say when the printing job was done. As you can see, these control characters are really quite archaic. They just don't really make any sense anymore with the computers we have today. So, aside from carriage return and line feed, they're really not used anymore. In fact, most programs today that deal with text are just going to ignore characters like the bell character. So say if a program displays text on the screen and there's a bell character in the text data, the program will probably display it as either a space or as no character at all.